Hi, good morning. So can you please confirm my voice is audible or not?
Audible, sir.
Audible, sir.
Okay, thank you for confirmation. Okay, so we start the session. So in previous class, we started discussing about Spark, and within the Spark, we discussed about what are the features of the Spark, and we discussed about what is the RDD, and we discussed about what is the data frame. We discussed about what all are the transformations we are having, and we discussed about actions. And we discussed about how to read data from files, and we discussed about DSL, which is nothing but domain specific language. And so these are the different topics. Other than this, we discussed some more other topics also. Just I'm giving the high level list here. These are all the different topics we covered as part of our previous sessions. Now in the today's session, we'll try to understand about our Spark architecture. So as part of today's session, we'll try to understand about Spark architecture. So if you remember, on the first day of the Spark session, we discussed about one of the statement called as Spark is going to follow what kind of architecture? If you remember, try to give the answer. Spark follows the sorry. So it is going to follow the kind of architecture called as nothing but we can able to call it as a master slave architecture. And what is the meaning of master here? Master is nothing but indirectly we can able to call it as a name node, and slave node is nothing but we can able to call it as nothing but our data node. So these few points we covered already as part of our previous session. Just I'm repeating as part of our Spark architecture. The Spark follows the kind of master slave architecture, and its cluster consists of single master and multiple slaves. As part of Spark architecture, we can able to see the single master and we can able to see the multiple slave machine. So master is nothing but we are going to have the one master machine which is going to act as a name node, which is going to contain all the metadata. And coming to slave node, it is going to act as a data node machine and it is going to contain our actual data. So like that, we are going to have the master slave architecture on top of our Spark. And one more important thing we need to understand here. The Spark architecture depends on mainly two abstractions, which we can able to call it as first one is nothing but RDDs, and second one we can able to call it as nothing but DAGs. So first one we can able to call it as a RDD, second one we can able to call it as a DAG. What is the meaning of RDD?
Resilience
It's nothing but resilient distributed data set. And DAG is nothing but we can able to call it as nothing but direct acyclic graph. So as part of our Spark architecture, these two are going to play the very important role. RDD is nothing but resilient distributed data set. DAG is nothing but is a kind of a direct acyclic graph. Already in the previous classes, we discussed about what is the meaning of RDD or what is the purpose of the RDD. So we can able to say it as the RDDs are the group of the data items that can be stored in where RDDs are going to store. If you remember, try to give the answer. It is going to store in the hard disk or it is going to store in the in-memory?
Hard disks.
It is
in memory.
In memory on your worker nodes. Okay, so please try to remember all these kind of words. And Spark is working completely in the in memory. Why we are moving from the MR to Spark? In the MR, every transformation is hitting your hard disk. But coming to Spark, what's happening here? Every transformation is happening on top of your in-memory or on top of your RAM only. So coming to here, as part of RDDs also, what is going to happen? All these RDDs are going to store everything on top of your in-memory. It is not going to store the data into your hard disk. Whatever the worker nodes we are going to have, or whatever the slave nodes we are going to have, in the slave nodes, in the in-memory, it is going to store all the RDDs. Now, out of RDD, what is the meaning of R? R for resilient. What is the meaning of resilient? So, try to recollect whatever we discussed on the resilient is nothing but a kind of a fault tolerant. Because of any reason, if your hardware is going to fail, your RDDs can able to restore automatically once it is going to back. That's kind of feature only we can able to call it as a resilient feature, or we can able to call it as a fault tolerant feature. And second one, D is nothing but distributed. So what is the meaning of distributed? As part of loading the data or as part of doing the data processing operations, your data is going to distribute among different nodes. Whatever the number of worker nodes we are going to maintain, or whatever the number of slave nodes we are going to maintain, in the all the slave nodes, your data is going to distribute. In the same way, here we can able to say data set is nothing but, it is nothing but, so we can able to call it as group of data. So this is the way, simply just we can able to recollect what is the RDD. Already in the previous classes we discussed about what is the RDD, but as part of Spark architecture, we are going to understand, we need to understand one more time about the RDD. For that reason, just I'm repeating the same topic whatever we discussed in the previous session. RDDs are nothing but resilient distributed data set. Resilient is nothing but, it is going to provide the fault tolerant because of any failures. If your hardware is going to crash, we can able to restore the data by depending on our requirement. That kind of feature we can able to call it as a resilient. Distributed is nothing but, as part of creation of the RDD, we are going to read the data from the files. That data is going to distribute among different nodes whatever we are having in our architecture. In the same way, data set is nothing but, it's a kind of a group of the data. This is the way just we can able to recollect what is the meaning of the RDD. Now in the same way, we need to understand about what is the DAG. So we can able to say simply, DAG is a finite direct graph that performs a sequence of computations on data. So we can able to say DAG is nothing but, it's a kind of a finite direct graph that performs a sequence computations on top of your data. Again, if you remember, when we discussed about the Spark features, we discussed one of the feature called as nothing but, Spark is a kind of a lazy evaluation program only. So what is the meaning of lazy evaluation? We discussed about one of the feature on top of the Spark. Compared to the MR, Spark is a kind of a lazy evaluation feature. What is the meaning of lazy evaluation feature?
Whenever we trigger the transformation, the action will be performed.
Yeah, perfectly correct answer. So we are having the transformation 1, transformation 2, transformation 3, transformation 4. Like this, we are having the multiple transformations. But as part of your programming, whenever we are going to write the transformation, immediately it won't trigger. So when it is going to trigger, whenever we are going to call the action, then only it is going to trigger all our transformations. And that kind of feature only we can able to call it as nothing but lazy evaluation feature. Now what will happen here is, whenever we are going to create the transformations, internally it will create a execution plan. What is going to happen as part of creation of the transformation? For every transformation, internally it is going to create a execution plan, and whenever we are going to call the action, what will happen is, it will create the DAG, and within the DAG it will capture complete execution plan. So whatever the execution plan it is creating, that is going to capture on top of your DAG, and within the DAG we can able to see it in the graphical representation. Whatever the DAG or whatever the execution plan we are discussing, that entire execution plan we can able to see it in the graphical representation in your DAG. Now, who is performing all these operations? Are we involving anywhere as part of these operations? We are nowhere involving here only, because all these operations are happening internally. Whenever we are going to write the program, whenever we are going to run the program, internally all these things are going to happen. But as a data engineer, if you are going to work as a 3 to 4 years of experience, we need to have some minimal knowledge about what is happening internally. For that reason, we are discussing about the Spark architecture. As part of discussing Spark architecture, we need to understand what is the RDD and what is the DAG. And coming to DAG, what is going to happen? It is going to contain all the task information, or it is going to contain the execution plan in the graphical representation. That kind of graph we can able to call it as nothing but direct acyclic graph, or simply we can able to call it as a DAG. Okay, now just I will show you one sample diagram here. With that you can able to get the clear picture. If you see, just I'm writing the code like this, and if you see here, by using this code, what I'm doing, I am reading the data from text file. After that, on top of the text file, we are going to perform the flat map operation. On top of that, we are going to perform the map operation. On top of that, we are going to perform the reduce by key operation. On top of that, we are going to save that entire result as a text file. Now you try to give the answer. This counts is going to act as a RDD, or this counts is going to act as a data frame. Try to give the answer. whatever the variable I'm showing you on the screen counts, this counts is going to act as a RDD or it is going to act as a data frame.
Data
RDD.
Data
RDD.
frame? RDD? What's the
Yes.
correct answer?
RDD.
It's a RDD and so indirectly you can see here
Spark
saying nothing but we can able to call it as a Spark contest. Whenever you are going to create the data frame, if you want to read the data from the file, what is the line of the code we have written? Spark.read.csv or Spark.read.parquet. That is the code we have written on top of your data frame. But whenever you want to create the RDD by reading the data from the file, then we can able to use the method called as a text file. By seeing the methods only, you need to understand whether we are creating the RDD or we are creating the data frames only. And within the RDD, we discussed about some transformations called as flat map and reduce by key. Now indirectly what I'm doing here, with the help of some transformations, I am creating a RDD. After that, we are saving the results into a particular file. Now this is the line of the code we have written. Now as part of execution of this code, what will happen internally? It is going to create a direct acyclic graph. How it will create it is here. Just I will show you that. So see here, this is the sample graph only. Whatever the code I showed you here. So this is the code. In this code, it is reading the data from test file. Then it is performing the flat map. On top of that, it is going to perform the map operation. On top of that, it is going to perform the reduce by key operation. Whatever the transformations we are applying here, by considering all these transformations, it will create the tasks, and all those tasks are going to represent in the graphical format as part of our execution internally. That graph only we can able to call it as a the way you can able to see the how we are seeing the direct acyclic graph. If you see first step, it is reading the data from test file. Second step, it is performing the flat map operation. On top of that, it is going to perform the map operation. Then it is going to perform the reduce by key. Then it is going to perform the save as text file. Indirectly, whatever the transformations we are applying on top of your code, with the help of that code, it is going to create the DAG. Again, the same question. Who is going to create this DAG? As a user, you are creating this DAG, or this DAG will create automatically?
It will create automatically.
It will create automatically. So whatever we are discussing here, no, don't scare or don't worry about anything, Sandy, because all these operations are happening internally. Just you are going to write the code. Once we are going to run the code, internally all these things are going to happen. Whatever the code we have written, on top of that code, it is going to create the DAG. Within the DAG, what we can able to see? We can able to see all the task information, or we can able to see our execution plan information in the graphical format. That only we can able to call it as a DAG, or we can able to call it as a direct acyclic graph. Okay. Now these are the few terminologies we need to understand before understanding about our Spark architecture. Now we'll try to understand what all are the components we can able to see within the Spark architecture. Just observe. So this is our Spark architecture only. So we can able to see the driver program. Sorry, 1 second. So here we can able to see driver program. By using the driver program, it is going to create the Spark contest. After that, we can able to see the cluster manager. Then we can able to see the worker nodes like this. Within the worker node, we can able to see the executors. Within the executors, we can able to see the tasks. Okay, all these are the different components we can able to see on top of our Spark architecture. Now we'll go one by one. Andy, in the Spark architecture, what kind of architecture we are going to follow? We are going to follow the master slave architecture, which is nothing but we can able to see the one master node and we can able to see the multiple slave nodes. Andy, now in this diagram, you try to give the answer which is the master node and which is the slave nodes. Any guesses? I know we didn't discuss about this, but by seeing the diagram, you try to understand what is the master node we can able to call and what is the driver nodes we can able to call here.
Yeah, cluster manager is the manager.
Cluster manager.
Master nodes and worker nodes are the data nodes.
Yeah, so see here we can able to say whatever the driver program we are having, that is going to communicate with the cluster manager, that we can able to call it as nothing but our master node. And as I told you earlier, as part of Spark architecture, we are going to maintain the one master node and we are going to maintain the multiple worker nodes. Only in this diagram, just I am showing you the only 2 worker nodes, but by depending on our requirement, you can able to create any number of worker nodes as part of creation of our cluster. While creation of the cluster, you can able to define how many master nodes you are looking, how many worker nodes you are looking. Based on that, it is going to create all the nodes on top of our cluster. But as part of the cluster, we can able to see the master node and we can able to see the worker nodes. Now here, these we can able to call it as a worker nodes, and driver program, whatever the program we are going to run, it will come to the driver program. With the help of the driver program, it will go to the cluster manager, and cluster manager is going to act as nothing but it's a kind of a resource manager. It is going to provide the information how many number of worker nodes we are having, or how many number of resources we are having, or how many number of executors we are having. All this kind of information we can able to get with the help of the cluster manager. This is the high level overview only. We are having the driver program. Within that, it is going to create the Spark contest. After that, we are going to have the cluster manager and we are going to have the worker nodes. All these are the different components we can able to see on top of our Spark architecture. Now we'll try to understand one by one what is the purpose of driver program, what is the purpose of cluster manager. We'll try to understand all this information, but before that, just to try to understand at the high level what all are the components we can able to see in the Spark architecture. We can able to see driver program. Within that, we can able to see the Spark contest. Then we can able to see the cluster manager. Then we can able to see the worker nodes. Within the worker nodes, we can able to see the executors and we can able to see the tasks. Now we'll try to understand what is the purpose of your each and every component here. We'll go one by one. First one is nothing but driver program. So we can able to say here, whenever we are going to submit our Pyspark program, it will go to driver program. So whenever we are going to trigger our Spark application, what is going to happen here in the first step? It is going to the driver program. After that, what will happen is the driver program is a process that runs the whole function of the application, and it will create the Spark context object. So what is going to happen whenever we are going to submit our Pyspark program, or whenever we are going to run the Pyspark program? If you remember, earlier we ran the Pyspark, we have written the Pyspark in the PyChart. After that, we ran the PyChart program, right? So internally, what is going to happen whenever we are going to run the Pyspark script? It is going to the driver program. What driver program will do here? It is going to see the whole functionality of your program. With that, it is going to create the Spark contest object. For the reason, as part of this architecture, we can able to see within the driver program, we can able to see the Spark contest, which is nothing but whenever we are going to run the program, it will come to the driver program. With the help of the driver program, what is going to happen here? It is going to create the Spark contest. Now we need to understand what is the purpose of the Spark contest here. So what Spark contest will do here is, Spark contest will coordinate with the Spark applications which are running on your cluster worker nodes. So whatever the worker nodes we are having, in those worker nodes, our Spark application is going to run. So what this Spark contest will do here, it is going to coordinate with the Spark applications which are running on, which are running on cluster of your worker nodes, or we can able to say which are running on your worker nodes only. Whatever the Spark contest it is creating with the help of the driver program, that Spark contest is going to coordinate with the Spark applications which are running on top of your worker nodes. At the same time, here what will happen is, to run a cluster, the Spark contest connects to different types of cluster managers, and then it will take care of below tasks. So what is going to happen here is, after creation of the Spark contest, what will happen here? Spark contest is going to perform the operations on top of your worker nodes. If you observe here, this Spark contest only is going to perform all the operations on top of your worker nodes only. But before performing the operations on top of your worker nodes, what is going to happen? This Spark context is going to connect with the cluster manager. Why it is going to connect with the cluster manager is nothing but to perform the below tasks, which are nothing but first one we can able to say it acquires executors or nodes in the cluster. So what is going to happen here? Spark context is going to communicate with the cluster manager. After communicating with the cluster manager, spelling mistake, it will acquire all the executors or it is going to acquire all the nodes in the cluster. Now see, actually this is the indirectly acting as a kind of our master node. Now this master node don't know about how many number of worker nodes we are having or how many number of executors are required for the purpose of running the program. For that reason, what Spark context will do here, it is going to connect with the cluster manager. With the help of the cluster manager, it is going to contact all the worker nodes only. From each and every worker node, it is going to acquire all the executors. Now in this example, if you see, we are having the 2 worker nodes. In the 2 worker nodes, we are having the 2 executors. Spark context will try to acquire these 2 executors with the help of the cluster manager. Without having the cluster manager, Spark context cannot able to perform this operation directly on top of your worker node. For that reason, Spark context will connect to the cluster manager. With the help of the cluster manager, it will acquire all the executors whatever we are having on top of your worker node. After that, what will happen here is, in the second step, then it sends your application code to the executors. What is going to happen? After acquiring all the executors information, then your Spark context will send your application to the executors, and application code can be defined by any cases where we are going to define our application code as per our understanding. Whatever the application code it is sharing to the executors, where we are defining all that application code
driver
in our Pyspark program. Yeah, in the driver only we are having that, but as a user, where you are defining all your application code, you are defining all your application on top of your Pyspark script or on top of your Python script only. In the Python script, whatever the application code you have defined, that application code is going to the executor. Now tell me, overall on top of this architecture, where your code is going to run? Your entire code is going to run on top of your worker node. Within the worker node, where your code is going to run? In the executors. Within the executors, where your code is going to run? In that task only. Indirectly, whenever we are going to run the program, your program is coming to the driver program. With the help of the driver program, it is going to create the Spark context. But don't assume that your program is running on top of the driver program. Your program is not running on top of the driver programming only. So what is going to happen here? Whatever the code we submitted, that entire code will come to the worker node. Within the worker node, it will come to the executor. With the help of the executor, your application code is going to trigger. With that, you can able to fetch the results only. But tell me, from the driver program to worker node, who is going to share the application code? Who is sending the application code here? We can able to say Spark context. This Spark context is going to share all the application code from the driver program to your worker node. Within the worker node, it is sharing all the program to the executor. But how Spark context can able to understand how many number of executors it is having, how many number of worker nodes it is having? To understand that information only, it is contacting the cluster manager. With the help of the cluster manager, it will fetch all the executors information. After fetching the executors information, it will share entire application code to your each and every executor. With that, it is going to create the task. With that, your program is going to trigger on top of your executors. This is the way we need to understand how your Spark program is running internally. Now I will ask one by one question. You try to give the answers only. Whenever we are going to trigger the Spark program, where it is going to reach in the Spark architecture? First step. In this whole architecture, where it will reach whenever we are going to submit the Spark program. Spark context or driver program. First step, it will reach to your driver program. Okay, don't give the answer Spark contest and the Spark contest is comes as a second step here. In the first step, whenever we are going to trigger our program, what will happen? First step, it will come to your driver program. With the help of the driver program, what is going to happen here? It is going to create the object called as nothing but Spark contest object, that we can able to call it as a second step. In the second step, with the help of the driver program, it is going to create the Spark contest object. Now, what is the third step? Any guesses? What is the third step? Directly it will send the application code to the executors, or it will acquire the executors with the help of the cluster manager.
Help of the cluster manager.
Yeah, third step is nothing but Spark contest will reach out to the cluster manager. With the help of the cluster manager, it will acquire all the executors and whatever the executors we are having in the cluster, it will acquire all the executors information by reaching out to the cluster manager, that we can able to call it as a third step. In the third step, Spark contest will reach out to the cluster manager. Cluster manager will share the information of how many executors we are having or how many worker nodes we are having. All that information Spark contest can able to get with the help of the cluster manager. That is the third step. In the fourth step, what is going to happen? Once a Spark contest can able to understand how many number of executors we are having, with that it will share all the application code to your each and every executor. Whatever the number of executors we are having, in all those executors, it will share the application code. Then all that application code is dividing it as a individual task country. With that, your code will execute on top of your executor. With that, it is going to fetch all the results. This is the way we need to understand how your program is going to run internally with the help of all these components. Okay, now you try to give the answer. Out of all these components, which component is going to act as a resource manager? What is the meaning of resource manager? Resource manager need to understand how many number of nodes we are having and how many executors we are having, how many number of nodes are working properly, how many number of nodes are not working properly. All this kind of information need to capture by using the resource manager. Now, in this whole architecture, which component is going to act as a resource manager indirectly?
Cluster
Manager.
Obviously, we can able to say cluster manager and D. So that's the reason, try to understand each and every point I'm trying to explain. With that, it is very easy to understand about the Spark architecture. Generally, people are feeling understanding Spark architecture is very complex and D, but it is very easy. Just you need to understand step-by-step operation. Once you can able to understand the step-by-step operation, with that, it is very easy to understand what is happening on top of your internal Spark architecture. Just I will repeat one more time. Whenever we are going to submit the program, it will come to the driver program component. With the help of the driver program component, it is going to create the object called as a Spark contest object. What is the purpose of the Spark contest object? It need to share the code to the executors, but before sharing the code, Spark contest need to understand how many worker nodes it is having, how many executors it is having. It need to get all that information. From where it can able to get the information? From the cluster manager, it can able to get the information. For that reason, in this diagram, we are given the link between the Spark contest to cluster manager. Spark contest will reach out to the cluster manager. With that, it will try to understand how many executors we are having or how many worker nodes we are having. After fetching this information, then what will happen? Spark contest will share all the code to your all the executors, and after that, that application code is dividing into the individual tasks. With that, your code is going to run on top of your executor. With that, it is going to fetch the results. With that, you can able to get the data on top of your output. This is the way simply we can able to understand how your Spark architecture is going to work in our internal system. Okay, so far we have discussed about driver program. Within the driver program, we discussed about what is the purpose of the Spark contest. Now, just I will write some points here. What is the purpose of cluster manager? The role of the cluster manager is to allocate resources across applications. And we need to understand here, the Spark is capable of running on large number of clusters. So with the help of the Spark, we can able to create the big clusters, and which is nothing but you can able to create the 100 node cluster, or you can able to create the 150 node cluster, or you can able to create the small clusters also, 5 node cluster or 10 node cluster. But whatever the number of nodes we are going to maintain in the cluster, who is going to take care of all the resources and everything? Your cluster manager will take care of all the resources and everything. At the same time, here we need to understand one more important statement. Cluster manager consists of different types of cluster managers, such as any cases, what are the different cluster managers we are having? This is the one more point again we discussed in the previous classes. How many ways we can able to submit the Spark program? One is in the cluster mode. Second one is nothing but our standalone mode. Okay, so we can able to submit the Spark in the two different ways. One is the cluster mode, other one we can able to call it as a standalone mode. If you remember, as part of cluster mode, we are going to use the either yarn or we are going to use the meshes. These are the two words we discussed in the previous classes. Indirectly, we can able to say yarn is nothing but is one of the cluster manager, or mesos is nothing but is a kind of a one of the cluster manager. And so in the cluster manager, either we can able to use the yarn or we can able to use the mesos. But what is the purpose of this yarn or mesos? What we can able to say? Yarn or mesos indirectly going to act as nothing but your cluster manager. What is the purpose of the cluster manager? It is going to take care of all the resources. At the same time, it is going to allocate the resources. And now indirectly we can able to say yarn is going to take care of all the resources and yarn is going to allocate the resources. In the same way, mesos also going to take care of the resources. At the same time, mesos also going to allocate the resources based on your application. Indirectly we can able to say within the cluster manager, we are having the two different types of the cluster managers. One we can able to call it as a yarn, and other one we can able to call it as a mesos. As part of the yarn or as part of the mesos, what is going to happen? It is going to handle the resources. At the same time, it is going to allocate the resources. And now you try to give the answer here. What is the meaning of resource? Any guesses again? I am using the word called as a allocating the resources or handling the resources. But what is the meaning of the resource here?
Executor.
Here, resources are nothing but we can able to call it as the executors. And whatever the executors we are talking or whatever the worker nodes we are talking, that indirectly we can able to call it as a resources. Already we discussed about cluster manager can able to understand how many worker nodes we are having, or cluster manager can able to understand how many executors we are having. Indirectly, the executors or worker nodes, all these things we can able to call it as a resources. For that reason, just I'm giving the statement, cluster manager can able to handle all the resources of your cluster. At the same time, cluster manager will allocate the resources as part of our program execution. Now you tell me, I am giving the statement called as nothing but cluster manager will allocate the resources. And but tell me to which component it is going to allocate the resources. Try to give the answer again. Cluster manager will allocate the resources. That is the perfect statement. But to which component it is going to allocate the resources?
Executor.
The executor.
Spark contest.
It will assign the executors, or it will assign the worker nodes, or it will assign the resources to your Spark contest. And from the beginning onwards, we are discussing Spark contest need to run the application code. To run the application code, it need to get the worker nodes, it need to get the executors. Indirectly, we can able to say Spark contest need to run the code with the help of the resources. But from where it can able to get the resources? With the help of the cluster manager, it can able to get all the resources. For that reason, we can able to say cluster manager is going to allocate the resources. But to what it is going to allocate the resources? It will allocate all the resources to your Spark contest. With that, Spark contest will send the code to your all the resources or all the executors. After that, it is going to create the task. With that, your program is going to run. With that, you can able to get the results. This is the way we can able to understand what is the purpose of the cluster manager. In the simple words, we can able to say cluster manager role is nothing but to handle the resources. At the same time, to allocate the resources, we are going to use the component called as nothing but cluster manager. In the same way, any guesses what is the purpose of the worker node? As per our discussion so far, what is the purpose of worker node? We can able to say, yeah, correct. We can able to say first, worker node is going to act as nothing but it's a kind of a slave node. At the same time, we can able to say role of worker node is to run the application on top of your cluster. Now here I'm giving the statement, worker node is going to perform the running your application. But again, you tell me within the worker node where it is going to run the program. In the worker node, your program is going to run, your application is going to run, but within the worker node, where it is going to run the program?
Execute.
On top of your executor, it is going to run. That's the reason I'm saying, Andy, try to understand every statement. With that, you yourself can able to give the answer. What is the worker node, or what is the cluster manager, what is the driver program? That's the reason only just we are spending 30 to 40 minutes of time on the same topic. So worker node is going to trigger your application, or worker node is going to run your application. But within the worker node, where it is running your program, in the executor, it is going to run your program. So we can able to say one more statement here. What is the executor?
So, where is the cluster here in this
This entire
architecture?
thing we can able to call it as a cluster. So this worker node or this master node, this collection of this all the nodes only we can able to call it as a cluster.
Okay.
Okay. So cluster is nothing but it's an executor. Is a process launched for an application on worker node. So we can able to say simply executor is a process which is launched for an application on top of your worker node. Within the worker node, your application is going to trigger, but to run this application, it is launching a process. That process only simply we can able to call it as nothing but our executor. Okay. At the same time, we can able to give the one more statement here. Executor will run all the tasks and keeps data in memory. Your executor is going to trigger all the tasks, and with that, whatever the result we are getting here, all that result is going to store on top of your in memory. At the same time, with the help of the executor, it can able to read and write data to the external sources. Because we need to read the data, at the same time we need to write the data. Who is going to take care of all these kind of activities? Again, we can able to say executor only is going to take care of all these kind of activities. So executor is a process which is launching as part of your application running in our worker node. At the same time, executor is going to trigger all the tasks. At the same time, whatever the results we are getting, that results are going to store in the in memory. After that, with the help of the executor, either you can able to read the data, or we can able to write the data on top of your external sources by depending on our requirement. Now finally we need to understand last component called as nothing but task. So task is nothing but simply we can able to say it's a unit of work that will be sent to one executor. So task is nothing but a kind of just a unit of work only. Whatever the work it need to perform, or whatever the transformation it need to trigger, for that it is going to create the task. Task is going to run with the help of the executor. Executors are running on top of your worker node, and Spark context is going to share all the code to your worker node. With that, worker node will share that information to the executor. Executor is nothing but it's a kind of a process. With the help of the executor, it will run all the tasks whatever we define in our code. With that, your whole program is going to run. After that, at the end of the program, if you want to perform the write operation, with the help of which component it is going to perform the write operation? With the help of executor, it is going to perform the write operation. At the same time, with the help of which component it is going to perform the read operation? Again, same with the help of the executor only, it is going to perform the read operation. This is the way simply we can able to understand what all are the different components we can able to see on top of your Spark architecture. And you need to understand what is the purpose of your each and every component on top of this architecture. So this is the way you can able to understand how Spark architecture is working internally whenever we are going to run the program. Don't ask me the question, sir, why we need to understand all this information? Why we need to understand? It's very simple. You are going to work as a 3 to 4 years of experienced person. If you are going to work as a 3 to 4 years of experienced person, you should understand internals of the Spark or what is happening internally. For that reason, definitely you need to understand about all these kind of concepts. At the same time, as part of interviews also, you will get one question on top of your Spark architecture. So they will ask the question, can you please explain about the Spark architecture? You should be in the position to explain about the Spark architecture. That is the one more reason we are discussing this whole architecture as part of our session. Okay, up to here, any questions or confusions, please ask me.
Sir, here driver program is the master, right?
Yep.
And in terms of Spark context, we don't have to trigger it or use it manually from the program.
No, in the program, if you remember, we are creating the Spark session, we are creating the Spark contest. If you remember that, with the help of those lines of the code, it is going to create the Spark contest.
Yes, sir, but Spark context we use in RDTs only, right?
Yeah, correct. So, for example, say if you are discussing about the RDT, it is going to create the Spark contest. But if you are going to create the data frame, what will happen instead of Spark contest? Here we can able to call it as a Spark session.
Spark session.
Just in the representation, I'm showing it as a Spark contest, and this whole architecture we are discussing from the RDD perspective. Same architecture you can able to discuss from the data frame perspective also. But if it is the data frame, what will happen instead of having the Spark contest, you can able to say it as a Spark session.
Okay, sir. And regarding this mode, this all this architecture is valid for only cluster mode or standalone as well?
No. See, this is valid for cluster mode. At the same time, same thing is going to valid for the standalone mode also. But tell me, as part of standalone mode, are we going to see the worker nodes or we are going to see the only single node? If it is a standalone mode,
Single.
it is a single node, which is nothing but same node is going to act as a master, same node is going to act as a worker. Indirectly, whatever the master node we are having here, same master node we can able to see it as a worker node. See, standalone is nothing but you are going to have the single machine. Within the single machine only you are going to maintain the master node. At the same time, in the same machine you are going to maintain the name slave node also, which is nothing but this is applicable for both cluster node. At the same time, it is going to applicable for the standalone mode also. But in the standalone mode, what is going to happen? Whatever the single node which you are going to maintain, same node is going to act as a driver program and same node is going to act as a worker node. And in the same node, you can able to see the Spark context. In the same node, you can able to see the executors and task information, because you are using the standalone mode or you are using the single node. For that reason, single node will take care of all these kind of responsibilities on top of your standalone mode.
Okay, sir. So in terms of standalone mode, cluster manager is there is any role to it, or
there is no important role for the cluster manager, because within the node only we are having the master node and slave node. In that situation, no need to worry about from where it need to get the resources, from where it need to get the executor. That's the reason, as part of standalone mode, cluster manager is not going to have any kind of role.
okay, sir, got it.
Okay. Okay, so this is the way simply we can able to understand how our Spark architecture is going to work in our internal systems only. And one more important thing we need to understand here. So far, if you remember, whenever you are going to run Spark programs, how we are running so far? First option, by using command prompt, we are running individual lines of the code. Second option, with the help of the PyCharm, you are writing the script and we are running the script from PyCharm itself. But in the real time, what will happen is we will write the code in the PyCharm. But if you want to run the PyCharm scripts only, or if you want to run the Pyspark script here, we are not going to run the Pyspark script directly in the PyCharm. So in the real time, what will happen is we are going to use the command called as nothing but Spark submit command. So this is the command we are going to use for the purpose of triggering our Spark application. Don't get any kind of confusion, Sandy. So far, we are writing the programs in the PyCharm. With the help of the PyCharm only, what we are doing here, simply we are going to run the program. Just by right click on that, we are going to click on the run application. That is the way we are running the program so far as part of our practicals. But if we are going to work in the real-time projects, directly you are not going to run the programs on top of your PyCharm only. As part of development phase, you can able to run the programs in the PyCharm. But if you are going to deploy the code into the higher environment, in the higher environments, we are going to run all our scripts, or we are going to run our Pyspark program with the help of the command called as a Spark-submit command only. By using this command, we can able to submit our Pyspark applications on top of your standalone mode or on top of your cluster mode. Now, if you remember, as part of creation of the Spark session, we discussed that one method called as a master. Within this, we given it as a local of 1. If you remember, what is the purpose of this master? As part of creation of the
Into
Spark
one
session,
code.
we are using the master.
In which
What is
mode
the
we
purpose of the
can
master?
do
By
type
using
of
the
mode.
master, you can able to define whether you want to trigger it in the cluster mode or you want to run it in the local mode. That information we are giving with the help of the master. Now, what I'm telling here, after writing your whole program, if you want to trigger the program, what we can do here with the help of the Spark-submit command, we can able to trigger our Spark applications. But from where we have to trigger this Spark submit command, we can able to say from your command prompt, or we can able to say from your Unix prompt, or we can able to say this Spark submit we can able to trigger with the help of our any one of the orchestration tools, which is nothing but by using either Airflow or by using Databricks or with the help of controller. So all these are nothing but different orchestration tools we are having, and in this orchestration tools also, whenever we want to run the Spark application, simply we are going to use the command called as nothing but Spark submit command. With the help of this Spark submit command, simply we can able to submit our Spark program. With that, it is going to run either on the standalone mode, at the same time it is going to run on top of your cluster mode by depending on our requirement. Again, I'm repeating, don't get any kind of confusion. So far, whatever the Spark program we have written, all the Spark programs we are running with the help of the command prompt. Second option we tried with the PyCharm. Now what I'm telling here, once you are ready with your script, if you want to trigger the script, we are having the one more option, which is nothing but with the help of the Spark-submit command, we can able to trigger the Spark applications by depending on our requirement. But if you want to use this Spark-submit command, we need to understand the syntax of the Spark-submit. Let's see here. Okay, so this is the syntax we need to follow only. Now, if you observe, I'm giving the two different syntaxes. One is for if you want to run it in the local mode, we have to go for the first syntax. Second one is nothing but if you want to run it in the cluster mode, then we can able to go for the second syntax. Now, just we'll try to run it in the local mode. With that, you can able to get the picture how we can able to trigger the Spark-submit command for the purpose of triggering our Pyspark programs or for the purpose of triggering our Spark applications. And now, if you remember in the previous classes, we discussed about one of this example. So just I'm opening it in the Notepad++. If you see this program, what we are doing in this program, we are importing the Spark session. After that, we are creating the Spark object. After that, we are reading the data from the CSV file. After that, just we are performing some group by operations and average operation. This is the one of the example we discussed in the previous classes, and we ran this example with the help of the PyCharm. Now, my requirement is without using the PyCharm, with the help of the Spark-submit command, I want to trigger this program or I want to trigger this application. For that reason, what we have to do here, from where we need to run the Spark submit command, either from the command prompt or from the Unix prompt only. At present, I'm working on the Windows application. For that reason, just what we have to do here, we need to open the command prompt. So what I will do here is, from here only, I will open the command prompt. Just I'm giving the CMD, click on enter. Otherwise, what we can do, if you want to open the command prompt, we can go to the start. From the start also, we can able to open the command prompt. But what I'm doing here, just I'm opening a particular folder. In this folder, already I'm having my PyCharm script or Python script only. Now, from this folder, just if I'm going to give the CMD command, just observe what's going to happen. What's the advantage now? Directly, you are landing into the same path only. We are landing into the D drive Qt-20. For example, if we are landing from the start button, what's happening? We are landing into the C drive users Dell. Now, for example, here I'm giving the Spark-submit command. Now here I need to give the program name. How we need to give the program name? What's the program name here? This is my program name. Okay, so now tell me if I'm going to run this program, it will work or it will give any kind of error.
Error.
Do we have this program in this path or we are having this program in this path? D drive Qt-20. We are having this program in the D drive Qt-20, which is nothing but you have to provide the complete path. You have to give D drive :/Qt/ you have to give it as a -20/. This is the way we have to give the complete path only. Now, just what I'm telling here is instead of giving the complete path, if you want to simplify this, what we can do, whatever the path you are having your application or your program, from there, just to directly give the command. With that, it is going to open the command prompt. Here you can able to see the direct path D drive qt-20. Now here instead of giving the complete path for your script, directly you can able to provide the script name. And for that reason, just I'm launching the command prompt from here directly. After that, what we have to do here, we need to provide the Spark submit command. This is the command I'm giving, spark-submit. After that, we are given the one of the argument called as nothing but master argument. With the help of this argument, you are going to specify whether you want to run it in the local mode or you want to run it in the cluster mode. If it is in the cluster mode, you have to specify whether you want to run it in the yarn mode or you want to run it in the meshes mode. But for now, we are triggering this application in the local mode. For that reason, just we are giving spark-submit. After that, we are giving --master. Then we are giving the local. Then we are giving our script name and now just we need to click on enter. Now what we are doing indirectly by using this command, try to give the answer. With the help of this command, what we are doing, just we are triggering our Pyspark application. Whatever the Pyspark program you triggered earlier in the PyCharm, same program we are triggering with the help of our spark-submit. But why suddenly we are discussing about the spark-submit? Because in real-time projects, if you are going to work in the higher environments or in the real-time projects, if you are going to use any kind of orchestration tools, there we are going to use the spark-submit command to submit our Spark applications. For that reason, compulsory you need to understand what is the purpose of the Spark submit, and you need to understand how we need to use the Spark submit for the purpose of our program execution. For that reason, we are discussing about this Spark-submit. Just will wait for a few seconds. It will take some time. So meanwhile, what we'll do here is, so I have the two different windows only. In one window, my program is running. Now, for example, if you want to see what all are the different options we are having in the spark-submit, just do this command. Spark-submit space --help. Okay. So once we are going to get the spark-submit help, it is giving all these options. And indirectly, if you observe here, we are having the so many number of options as part of we can able to pass on top of your Spark submit. But whatever the program just now we submitted, which argument we have used there? We used the --master. That is the one of the argument we have used on top of your spark-submit. It's running now. See, spark-submit, we are using the --master. In this --master, what we are given here, we given the local. Okay, if you observe in the --master, by depending on our requirement, we can able to provide the local, or we can able to provide the meshes, or we can able to give it as a yarn by depending on our requirement. Like that, here we are having the so many different arguments. And now we are not going to cover all these arguments here. But if you want to go through all the arguments, what you can do here is just to give the simple command. I will put it in the notes. So with the help of this command, you can able to understand what all are different arguments which we can use as part of Spark submit application. So by using this small command, you can able to go through all the list of the arguments which are available on top of your Spark-submit application. Now in our example, just we are using the one of the argument called as a --master. With the help of this, we are defining I want to trigger my application in the local mode. For that reason, we are given the --master. After that, we are given the local. With that, we can able to trigger our application in the local mode execution or in the standalone mode execution. Now just we'll see the results now. Yeah, now see here. It is giving so many number of logs, and all these are the operations happening internally. But if you observe mainly, okay, so if you see the program, few seconds, and something happened to my system. Okay. If you see this program, here in the first step, what I'm doing, I am reading the data from a particular file. After that, what we are doing, we are given the option called as a data.show. What is the meaning of show? It will display the data from your data frame. Okay. After that, what is the next command I given? I given the print schema. What is the meaning of print schema? What is the purpose of print schema?
Structure.
It will print the structure of your file. Now, once we are going to run this program, what need to happen? It need to read the data from the file. After that, it need to display the data by using the show command. After that, it need to print the schema. Now we ran this program with the help of the Spark submit. Now in the command prompt, you can able to see all the outputs like this. And the first output, we are getting the data with the help of the show command. After that, we given the print schema. With that, you are going to get the structure of your file. After that, see, we are getting the output as a total number of rows, because in my program, I have written print the total rows by using the command called as a count transformation. With the help of this transformation, you can able to get the total number of rows. After that, we are performing the grouping operation with the average function. With that, we are displaying the data. For that reason, it is displaying the one more record like this. Actually, earlier when we ran the same program on top of your pie chart, in the pie chart output, we are getting all the results. And in the same way, whatever the program we ran in the pie chart, we are running the same program with the help of the Spark submit. Now you tell me, from the execution perspective, is there any difference either in the pie chart or in the Spark submit? There is no difference, and whatever the way it is running in the pie chart, same way it is going to run in the Spark-submit also. But in the real time, instead of going to use the pie chart, we are going to use the Spark-submit for the purpose of submitting our applications in the higher environment. That's the reason just we are discussing about the one more approach, how we can able to submit our Spark-submit. Again, I'm telling it is very, very simple. Once you can able to understand the previous examples and previous scripts, and with that understanding, instead of running those scripts from the pie chart, simply we are triggering those scripts from our Spark-submit by using the command prompt. This is the way simply we can able to understand how we can able to utilize the Spark-submit for the purpose of triggering our programs. Okay. Any questions up to here? Please ask me.
Sir, in terms of Spark, will it use both RDD and data frames at a time, or any one of the any one?
Yeah, I can able to say in the real time nowadays most of the people are using the data frames, because as I told you, if you remember in the previous class I mentioned, compared to RDDs, in the data frames we are having the high level APIs, or we can able to call it as a high level transformations. And at the same time, compared to RDDs, coming to data frames, we can able to see the better performance. That's the reason nowadays in the real time projects, most of the people are, I can able to say all the projects are using the data frames only. In the real time projects, we are not going to see the RDDs. But for example, if the project started 8 years back or 9 years back or 10 years back, might be in such kind of projects we can able to see the RDDs. But whatever the projects recently started, in all those projects we can able to see the data frames only. We are not using the RDDs. But as part of interviews, might be you will get the questions, what is the RDD and what is the data frame? That's the reason try to understand what is the RDD. But if you are thinking from the real time perspective, I can able to say in the real time most of the times we are going to use the data frames only.
Yes, sir. Yes, sir. But anyone, right? Not both.
Yeah, anyone. So see, if you are using the RDD, we have to go with the RDDs, or if you are using the data frame, we have to go with the data frames. We are using any one of the thing.
Okay, sir. And in terms of this Spark execution, notebook is possible?
Yeah, with the help of notebook also you can able to perform the execution. See, it's nothing but indirectly it's a kind of a Python program only, right? In the notebook you can able to run the Spark programs also, but only thing is nothing but in that notebook we have to install the Pyspark. If you remember earlier, with the help of the notebook we ran the pandas, and as part of running the pandas program, what we did? First we install the pandas. With the help of the pip install pandas, we install the pandas. After that you can able to perform the some programs on top of the pandas. In the same way, with the help of the notebook also you can able to run the Pyspark program. And as part of running the Pyspark program, just you have to install the Pyspark on top of your notebook. With that you can able to run the Pyspark programs with the help of the notebooks also. Now within few minutes we are going to discuss about Databricks, and in the Databricks we are going to perform each and every operation on top of the notebooks. During that time I will show you how we can able to run the Spark programs with the help of notebooks. For now I'm not going to discuss just now. in, I think, if possible, in next 10 minutes or 15 minutes. Otherwise, in the tomorrow session, we are going to see the Databricks. In the Databricks, every operation we are going to perform on top of the notebook. During that time, I will explain within the notebook how we can able to trigger our Spark programs.
So Databricks is the one affiliated with the notebooks.
Yeah, in the Databricks, actually, we are using for writing about all the Spark programs, and within the Databricks, we are going to perform most of the operations with the help of the notebooks.
Okay, sir. Okay.
Okay. Yeah. Any other questions up to here?
So all this Pyspark and all comes under the big data concepts.
Yes, correct.
So can we call it as big data architecture also?
No, it's not
No.
a big data architecture. It's a Spark. See, in the big data is a kind of a concept. Within the big data, we are having the Hadoop framework. Within the Hadoop framework, we are having the two main components. What are those two main components? What are the main components of your Hadoop?
HDFS and MR.
Yeah, perfect answer. HDFS for the purpose of storage, MR for the purpose of your data processing. Okay. Now Spark is not falling under the Hadoop, and Spark is a kind of a separate framework. So whatever the architecture we discussed so far, that we cannot able to call it as a big data architecture, is completely related to the Spark architecture only.
Sir, Spark, but in terms of Hadoop stack component, Spark is one of it, right?
No. Spark is not a Hadoop stack component, Andy. So we are calling it as, so some people are calling Hadoop, Spark is one of the Hadoop stack, but you tell me whether Spark is tightly integrated with the Hadoop.
Loosely coupled.
It's loosely coupled. Then how we can able to say it's a kind of a Hadoop stack? We can call it. I'm not saying we should not call it as a Hadoop stack, and you can call it as a Hadoop stack. But we can able to say without having the Hadoop also, we can able to work on top of the Spark, because in the big data, most of the times what will happen is with the help of the Spark, we are connecting to the HDFS files, and if for that reason people are calling it as it's a kind of a Hadoop stack. But by using the Spark, what we can do here, you can able to read the data from the HDFS. Otherwise, if you want, we can able to read the data from the GCS buckets. Otherwise, if you want, we can able to read the data from the S3 buckets. Otherwise, we can able to read the data from the ADLS, or we can able to call it as a Azure Data Lake Storage. For that reason, we can able to say it's a Hadoop stack, or we can able to say it's not a kind of a Hadoop stack. But why people are having that kind of perception is, most of the times we are using the Spark on top of our big data projects for dealing the data from the HDFS files, and if for that reason people are in the perception Spark is falling under the Hadoop stack. I am only saying that is the correct statement, but don't think that Spark is tightly coupled with the Hadoop. It's not tightly coupled, it's a kind of a loosely coupled, and either by using the Spark we can able to perform the operations on top of your Hadoop, or we can able to perform the operations on top of your cloud also, by depending on our requirements. Okay. Now with this, simply we'll try to understand some more concepts here. We'll discuss about what is Databricks. So we can able to say, with the help of Databricks, we can process, we can store, we can clean, we can share, we can analyze, we can model, and we can able to monetize data sets. So actually Databricks is kind of a third party application only, and actually this Databricks is available. Databricks is available in GCP, and it is available in Azure, and it is available in AWS also. So see here, whenever we are discussing about the Databricks, don't think that it's a kind of a GCP service, or it's a kind of a Azure service, or it's a kind of a AWS service only. It's not at all related to the cloud service. Databricks is a kind of a third party company, and this third party company launched the Databricks on all the clouds, which is nothing but Databricks is a kind of a application. We can able to say this application is available in the GCP, this application is available in the Azure, this application is available in the AWS also. But what is the purpose of the Databricks here? With the help of the Databricks, either you can able to process the data, or you can able to store the data, or you can able to clean the data, or you can able to analyze the data, or you can able to monetize the data. All these kind of operations we can able to perform on top of your Databricks, and all these operations we are going to perform with the help of Spark. We can able to say all these operations we can able to perform with the help of the Spark. Indirectly we can able to say, whenever we are going to work on top of the Databricks only, no need to install Spark separately, because your Databricks application by default it is coming with the Spark. That's the reason, as part of using the Databricks application, no need to install the Spark separately. By default it is coming with the Spark application. That's the reason, once you are going to create your Databricks account, or once you are going to create your Databricks application, on top of that directly we can able to trigger our Spark program is by depending on our requirement. Now might be you can able to get the question, sir, already we discussed about the command prompt, already we discussed about the PyCharm, already we discussed about the Spark submit, then again why we are discussing about the Databricks? Very simple, Andy, because with the help of the Databricks you can able to perform the different types of the operations. As I told you, you can able to perform the processing, storing, cleaning, sharing, analyzing, and you can able to perform the monetizing of your data. All these operations we can able to perform with the help of your Databricks. At the same time, Databricks can able to handle our cluster configurations also. With the help of the database, what is going to happen? We can able to handle our cluster configurations also. That's the reason I'm not saying that in all the projects, only in some of the projects people are going to use the Databricks. But see here, once you understand the Pyspark, or once you understand the Spark programming, you can able to run the same programs in the command prompt. You can able to run the same programs in the PyCharm, or we can able to run the same programs in the Databricks also. Now, as part of discussing about the Databricks, what we are going to do here is just we are discussing about in the Databricks application how we can able to run the Spark program, or how we can able to trigger our Pyspark application. So far we discussed about command prompt approach, and we discussed about PyCharm approach, and we discussed about the Spark submit approach, and Databricks is the one more kind of approach to trigger your Pyspark programs. But with the help of the Databricks, what other operations we can able to perform? You can able to perform the cluster configurations, or you can able to perform processing the data, storing the data, cleaning the data, sharing the data. All these different operations also we can able to perform with the help of the Databricks. Now you tell me, Databricks is given by which cloud platform? What's the answer? Databricks
It's a
given by which
what
platform?
you get
Yeah,
from
so
which
please remember the
application.
statement, Andy. Databricks is a kind of a third-party company. It's a separate company. It's not a kind of a cloud platform. It's a third-party company, but it is having tie-up with GCP, Azure, and AWS. It's a kind of a third-party company, but it is having the tie-up with GCP, Azure, and AWS. And actually, in the cloud side, we are going to use one word called as a cloud native services. Any guesses? What is the meaning of cloud native services? Just with your understanding, what is meant by cloud native services?
Which provided by
Original cloud
services in the cloud.
If cloud platform developed the service, that we can able to call it as nothing but simply cloud native service. And for example, if you are discussing about GCS, that is the one of the native service in the GCP. If you are discussing about BigQuery, that is the one of the native service we are having in the GCP. If you are discussing about, for example, S3, that is the one of the native service we are having in the AWS. So if that cloud platform is it is building that service, that kind of services we can able to call it as a cloud native service. Andy, now tell me, can we be able to call Databricks is a kind of a cloud native service?
No.
Simply we can able to say no, because it is not built by your GCP or AWS or Azure, and because Databricks is a kind of a third-party company. They came up with the kind of a application called as a Databricks application. With the help of the Databricks application, we can able to trigger our Pyspark programs, and we can able to manage the cluster configurations and everything. That's the reason we cannot able to call Databricks is a kind of a cloud native service. But with the help of the cloud, we are having the integration on top of your Databricks. That's the reason if you are going to work in the GCP or Azure, or if you are going to work on the AWS, in all these clouds, we can able to see the Databricks. By seeing that, don't think that it's a kind of a cloud native service. It's a kind of a third-party service which is hosted on top of your cloud. Now, for example, within the GCP, if you want to use the Databricks, Andy, within GCP, if you want to use Databricks, we need to create an account for Databricks. So if you want to use the Databricks on top of the GCP. What we have to do here, we need to create the account for Databricks. With that, in the GCP, we can able to perform all the operations on top of your Databricks. Now, once we are going to integrate GCP with Databricks. Now tell me, as part of creation of the cluster, while creation of cluster, Databricks will use what? Any guesses? Try to give the answer for this one. Just try to guess it. We are integrating GCP with Databricks. Otherwise, within the GCP, already Databricks is available. In the Databricks, I am going to create my account. I am going to open the Databricks application. Now, in the Databricks application, for example, I am going to create the cluster. While creation of the cluster on top of your Databricks, indirectly, from where it is going to take all the nodes, or from where it is going to take all the virtual machines. From where it will take all the nodes or virtual machines. Any guesses?
Dataproc.
From Dataproc.
Dataproc. No.
From the compute engine.
Perfectly correct answer, Andy. So see here, whenever we are discussing about the virtual machines, or whenever we are discussing about the nodes in the GCP, how we can able to create the virtual machines, or how we can able to create the nodes, Andy? With the help of your compute engine. Okay, Dataproc is a separate one that we are dealing for the purpose of handling our Hadoop cluster. That's completely different story. But tell me, in that Dataproc also, if you are going to create the cluster, indirectly where it is creating all the virtual machines? In the compute engine only. In the same way, with the help of the Databricks also, if you are going to create the cluster, what is the meaning of cluster? It's the collection of virtual machines, or we can able to call it as it's a collection of the nodes. And now, where all these virtual machines, or where all these kind of nodes are going to create on top of your compute engine. But where we are having the compute engine? Compute engine is present in the Databricks, or compute engine is present in the GCP?
GCP.
Compute engine is present in the GCP, which is nothing but Databricks indirectly what it is using? It is using the services of your GCP. That's the reason Databricks hosted on top of your GCP. And so once Databricks is hosted on top of the GCP, indirectly what is going to happen? Databricks is going to consume the services of your GCP. At the same time, Databricks can able to connect with your GCP services. For example, with the help of Databricks service or Databricks application, you can able to write Pyspark program. With this, you can able to read the data from GCS service. Because your Databricks having that kind of support, Databricks hosted on top of the GCP. GCP is having the GCS service. Now, with the help of the Pyspark program, simply we can able to connect to the GCS service. With that, you can able to read the data from your buckets, and you can able to write the data also into your buckets by depending on our requirement. Indirectly, what I'm trying to say here is, whenever we are saying Databricks is hosted on top of the GCP, what it means indirectly, Databricks can able to use all the services of your GCP. In the same way, if you are going to say Databricks is hosted on top of the Azure, what it means indirectly, Databricks can able to use all the services of your Azure. In the same way, if you are going to say Databricks is hosted on top of the AWS, indirectly what it means, Databricks can able to access all the services which are present on top of your AWS. That is the way you need to understand how Databricks is integrated with the different types of the cloud platforms. And again, I'm repeating, with the help of the Databricks, we can able to trigger our Pyspark programs. At the same time, with the help of the Databricks, we can able to perform the cluster configurations. At the same time, Databricks is a kind of a third-party company, and it came up with a kind of application called as the Databricks, and they hosted this application on the GCP and also Azure and also AWS. For that reason, Databricks, we cannot able to call it as a native services on top of your cloud platform. Instead of calling it as a native service, we are going to call it as nothing but it's a kind of a third-party service on top of your GCP or Azure or AWS. Okay, now we'll try to understand how we can able to create the Databricks in GCP.
Can we access buckets and all?
Yeah, you can
Like
access everything,
preview.
anything. You can access everything with the help of Databricks to your GCP.
So with separate commands or code.
That I will show you. So I will show you how we can able to access that.
Okay.
Okay. Yeah. So please open your GCP accounts. How to open the GCP accounts? Might be you forgot. How to open our GCP console, or how to open the GCP account?
Console.google.cloud.
Yeah, please give that console.cloud.google.com. Please give console.cloud.google.com. Okay. After that, so please select your project, in which project you want to work, please select that project. Okay, then please search for Databricks. In the search bar, please search for the Databricks. Once you are going to search for Databricks, here you can able to see the Databricks in the search result. Please click on that. You can able to see Databricks. Bottom you can able to see platform for data analytics and artificial intelligence workloads. You can able to see such result like this. Please click on that. Okay, so once you click on that, there you can able to get the Databricks page or Databricks console. There you can able to see the, so if you observe in my screen, I'm having it as a manage on provider, which is nothing but I already activated my account in the Databricks. That's the reason I am seeing the information like this only. But from your side, what will happen is, just 1 second, I will open one document. Okay, so you can able to see the information like this. Here you need to click on the subscribe. But just I'm thinking from my side, actually to complete all these steps, it will take minimum 30 to 40 minutes, but we are having the only 10 minutes of time. Okay, we'll do one thing. We'll stop here. So we'll create this Databricks account in the tomorrow session, and in the tomorrow session we'll do the practice on top of Databricks. With that, we won't go in the hurry mode, and otherwise we need to do this activity in hurry mode. And one more thing, what will happen is, as part of creation of Databricks account, it will take some extra time for each and every step. So to complete all this setup, definitely it will take 30 to 40 minutes of time. That's the reason, instead of going in the hurry mode, we'll create the Databricks account in the tomorrow session. But at the high level, I explained about what is the Databricks. In the tomorrow session, we'll create the Databricks account, and with the help of the Databricks, I will show you how we can able to run the Pyspark programs. At the same time, with the help of Databricks, what we can do here is we can able to perform the orchestration activities also. What is the meaning of orchestrations? We can able to schedule the jobs, and we can able to define dependencies between the jobs. All these kind of operations also we can able to perform with the help of the Databricks, and all those topics we cover as part of tomorrow session. First, we need to create the Databricks account. After creation of the Databricks account, we need to understand how to run the Pyspark programs in the Databricks. Then we need to understand how to run the Pyspark programs in the Databricks. Then we need to understand how we can able to perform the orchestration activities on top of the Databricks. At the same time, if you remember, when we are discussing about the Spark program, we can able to run the Spark applications by using two different ways. What are those? If you remember, try to give the answer. One is by using DSL, other one is
SQL.
Other one is nothing but with the help of Spark SQL. Spark DSL is nothing but with the help of the Spark domain specific language, or with the help of the Spark transformations, we can able to write the code. But same code we can able to write directly by using the Spark SQL also. But if you remember, in the pie chart, whatever the examples we discussed already, in those examples, we use the Spark SQL or we use the Spark DSL. Whatever the examples we discussed in the pie chart. We discussed by using the Spark DSL, which is nothing but indirectly we are having the one pending topic called as a Spark SQL. This topic also I will cover with the help of the Databricks study. With that, you can able to get knowledge on Databricks. At the same time, in parallel, you can able to understand about the Spark SQL. Like that, we can able to cover end-to-end topics on top of the Spark. Okay, that is the plan for our tomorrow session. Today we are not having other sessions, Andy. So that's all for today. In that tomorrow session, we are going to discuss about Databricks, and we are going to discuss about the Spark SQL. At the same time, we are going to discuss about orchestration activities on top of the Databricks. With that, we can able to get the clear picture how we can able to use the Spark with the help of the Databricks. Okay, and one more thing, tomorrow, if possible, I will take 3 sessions, Andy. So please prepare your minds accordingly. 8:30, 11:45, and 2:30. And in the 8:30 session, we'll try to discuss about Databricks. And in 11:45 session and in the 2:30 session, we'll discuss about what is the process we need to follow in real-time projects, and we'll discuss about step-by-step operations. At the same time, in real time, we need to use some other tools for the purpose of maintaining our code and for the purpose of checking our code and check out our code. And so all those are the topics we'll try to cover as part of our 11:45 and 2:30 sessions. We'll see in the 8:30 if we can able to complete Databricks well and good. Otherwise, I will extend the Databricks to the 11:45 session also. After that, in the 2:30 session, we'll discuss about what are the steps we are going to follow as part of our real time. That is the plan for today. We'll see how it goes as part of tomorrow's sessions, and accordingly we can able to plan. But for now, please think that tomorrow we are having 8:30, 11:45 and 2:30 session, and tomorrow we are going to have both online and offline sessions. So tomorrow we'll be back to Hyderabad and so tomorrow we are going to have the offline classes and also online. If anyone want to come to offline, please come to offline classes. Okay. And one more sincere request here. So tomorrow we are having demo session for new batch. That is at 10 a.m. 10 to 11:30 only. So 10 to 11:30. So this is for new batch. Okay, so tomorrow is the demo session. So our request is from our side or from quality side, if you are satisfied with our services and if you're satisfied with our course content, and if you're satisfied with all the knowledge, whatever we are giving, what you can do? Please refer your friends. Okay, so because we are spending good amount of time and we are trying to give lot of knowledge on top of the GCP data engineering program, but that is the statement from my side. But what I'm telling here, if you completely satisfied at the same time, if you are happy with the quality thought, at the same time, if you are happy with the knowledge, whatever we are sharing, please refer your friends. So with that, what will happen? They also can able to get the knowledge. At the same time, they also can able to get the jobs. And one more thing, as I told you already earlier, so on GCP, we are having good number of calls in market. And you can able to get the jobs also very easily on top of the GCP. So if any one of your friends are having the 3 to 4 years of gap, or if any one of your friends are struggling to get the jobs, and please suggest our course. So with that, they can able to come and attend the demo. After the demo, they can able to take the decision whether they want to continue the course or they won't continue the course only. But what is our request is from our side, please refer your friends if you are satisfied with all our classes and all our content, whatever we are sharing as part of our classes. Okay, that is one thing we are expecting from you. So from your side, what you are expecting from us? You are expecting complete knowledge and you are expecting real-time scenarios and everything. That in the same way, from our side, what we are expecting from you is you need to get the jobs. That's definitely one thing we are expecting. At the same time, so please try to give the references, and if you know any one of your friends, please give the references. So with that, people can able to join and they can able to understand the course and they can able to learn the course. With that, they also can able to get the jobs. Okay, but when you can able to perform all these things, if you are completely satisfied, then only please try to refer your friends, and with that, they will come and attend the new batch classes. Okay, any questions on this? And tomorrow
So
at 10
with the database,
Yes, please,
we are completing our concepts in GCP.
no, so still we are having few more. Okay, so I will tell you. So most probably by next Wednesday we'll complete the classes. Actually, I targeted for Sunday only, but I am unable to complete the classes by Sunday. So we'll try to complete the classes by next Wednesday. Wishing nothing but still we are having some topics. What topics I need to cross verify, but mostly after completion of database, we completed almost all the things. We'll see if any pending topics are there, I will cover. Otherwise, we'll talk about some other topics till Wednesday, and with that we can able to complete all the classes. See, this batch is starting from for the demo only. So don't think that once this batch is going to start, your batch is going to complete. It's not like that. Still, you are having the classes till Wednesday. So don't think like that. Tomorrow we are going to start the demo. It's not a
20th batch also completed on Wednesday.
sorry, can you please repeat?
20th batch కూడా complete అయిపోతుంది.
No. So no. 28 batch not completing only. So don't think like that. Only this is for batch 19. So batch 20, still we need to discuss so many other topics only. So batch 20 people, so still we are having the 20 to 25 days of classes. Don't think that it's not, this is not a statement for the batch 20. This is the statement for only batch 19 people.
Okay, sir.
Okay, yeah,
Sir,
it's my mistake. This is for batch 19. Okay, if no questions, we'll wind up for today's Sunday. So I will share all these notes. Please go through and practice all these things. Thank you all.
Sir, hello. 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 Hello, sir. Am I audible?
Yes, you're. I think, sir, not.
Yeah.
Guys, I just missed the last of the content. So today we have the 11:45 session.
No, today we
No.
don't have any classes yet. Today over. But
Okay.
tomorrow we'll be having 3 classes as well, sir.
Okay, thank you guys.